This lesson's on reading graphs. The learning target is I can read a graph to get information. And you should be able to understand the differences between the different types of graphs by the end of this. So if I look at these three different types of graphs, these are three types of graphs that we're probably pretty comfortable with, and they serve very different purposes. So if we look at this graph up at the top left-hand corner, this one right here, this is called a scatter plot. Scatter plot. And the reason why we use a scatter plot is to be able to tell the difference between, or the relationship between two variables. And we're trying to find the relationship between them. So in this case, we're looking at the daily height of bean plants, and we have time on the x-axis. The time is our independent variable. It's the one that changes, and the height is the dependent variable on the y-axis, and that's the one that is affected by the independent variable, right? So as time goes on, height is going to increase. As the height changes, the height doesn't affect what day it is. And so that's how we know the difference between the independent and the dependent variable. The independent variable will always be on the x-axis, dependent on the y-axis. And this is going to tell us the relationship between these two variables. So if we look at this data table, or this graph, we can tell that as time goes on, our height goes up. And so we can see a general trend through here. Now, scatter plots are not connected at dots. They're individual points because we can't put a dot right here because we didn't measure that. At 2.5 days, we didn't measure that time, so we can't put that data there. Now, we can draw a line of best fit, which we'll get into as we try to build graphs of scatter plots using Google Sheets. We can put a line of best fit and say that this is the general trend of this, but we don't actually have a data point that's right here. And so that's an important point to remember about scatter plots, is that we are not connecting these lines. They are just the data points that we measured to give us a general trend of those. And so scatter plots, when we have two separate variables. Now we have our graph over here, and this is called a bar graph. And we're going to use this when there's two variables, but we have separate categories on our independent variable. And so as you see down here, we have the type of company. We have GM, Ford, and Chrysler. The difference between this graph and the scatter plot is that the scatter plot, at the halfway point, there is a 4.5 days. And there is a 4.25 days, and there's a 4 3/4 days. So we have times in here that we could have measured data from. The difference between that and a bar graph is that I don't have a car that's half GM and half Ford, and I don't have a car that's half Ford and half Chrysler. And so this is called discrete data on the independent variable down here. This is called discrete data, and this is called continuous data. And that's because the data is continuous from here to here across our x-axis. And so that's going to be how you tell whether you're using a scatter plot or a bar graph. For a lot of the things that we do in physical science when we're measuring, like distances or with times, we're going to be using scatter plots to tell the relationship between those two variables. The bar graph is going to also let us see a trend here. It's going to be able to say that Ford sold more cars. You can see my dependent variable on the y-axis over here, the number of cars sold, and again my independent variable, the company, on the x-axis. So that's a bar graph. And then this one down here is called a pie chart. Pie chart. And this is going to be able to tell us, compare values relative to the whole. So as you can see here, I have a whole pie which represents all of the cars being sold among these three. And what a pie chart is going to give me is the percentages that Chrysler sold cars, and the percent of the cars that Ford sold, and the percent of cars that GM sold. So as you can see down here, we have GM sold 32.4%. I don't know how many they sold from this chart, but I know what percentage of the total cars that they sold. So that's a really important point with pie charts. They're going to be used for a completely different type of data than a scatter plot or a bar graph. They're going to tell us, relative to what everybody sold, how much did we sell at GM? Okay, And that's an important point between those. So we have three different types of plots for three different types of situations. Scatter plot gives us the two variables and tells us the relationship between those two variables. Bar graph is going to do the same thing. It can tell us the relationship between two variables, but it's going to be for discrete data of separate categories on our x-axis. And then our pie chart is going to give us information relative to the whole, more as a percentage than an actual number that was sold. And so depending on how you're going to use your data and how you collected it, that could affect how, like what type of graph you should use. So when we're reading a graph, we should be able to see all of the different information that's held on the graph, whether it's the variables or whether it's the title or the units. And so I'm going to add a title to this. We're going to go weight versus height. Just giving my dependent variable versus my independent variable. Because remember, this is a scatter plot, and this is going to show us the relationship between these two variables. So let's look for first my independent variable. And remember, the independent variable is the one that we change that affects the other one. And so in this case, our independent variable is the height, and our dependent variable would be the weight. Right here. And then if we're looking for our units, because remember, our units are really important. We want to know if are we measuring in pounds, are we measuring in ounces, are we measuring in kilograms? And here we are measuring in kilograms, and we're measuring our height in meters. So having all three of those aspects, the title, the independent variable, the dependent variable, and the units all spelled out on here is very important for our graph, because the purpose of a graph is to be able to communicate information with someone else. And so we have to make sure that they know how we did our experiment and how we measure these things. And so if I look at this graph, let's say I was trying to figure out how heavy, what would be the weight of someone if they were 1.7 meters tall. And this doesn't say that this is a person. I'm assuming that. That's why it would be important to add that in the title. If the purpose of this graph was to talk about how the height and weight of people were related, then it'd be really important to put that in there, because I'm assuming that this is just under 2 meters, so I'm guessing that would be right around, that'd be a pretty tall person, but definitely could be a person. So I'm assuming that's what this graph is, but that'd be an important thing to add in here. So if I was going to say how tall, or what is the weight of someone if there's 1.7 meters high, we go down on our x-axis, we look over to find 1.7, we get to here, and we try to draw straight up. Let's say we're right about there. And then we look over at our y-axis and we try to draw a straight line here. Graph paper is also really important if you're doing this on paper, or if you're doing it on sheets, it should have those minor lines, those minor grid lines for you. And so we would say that if someone was 1.7 meters high, they would be roughly 65 kilograms in weight. And so that's how we could see what the relationship is between these. If we said 1.5, we'd go right here, and then we go over to the side at about 53, maybe 53.3. We could estimate that for our height. And we could also add in a general trend line if we were doing this on Google Sheets, or if we want to take a ruler and try to draw a linear line, adding that to that. But remember, I didn't measure this point, so that is an estimate based off of the trend line. But that's how we can read a graph to get the information from an experiment.